Today we're going to look at the product rule and the quotient rule. So these are just two additional ways to take derivatives when you have a product or a quotient. And with this first one, look at the product rule. I'll read the statement. If u and v are differentiable at x, then so is their product uv, and then it gives you all of these cryptic symbols. So for the one that's kind of squared off in pink, this one, that is one way to write out the product rule. So to take the derivative of uv, you have u, multiply it by the derivative of v, and add that to v times the derivative of u. The way that I remember this most is the second form. So this is the part that I commit to memory. It's the same thing, it just has a lot less notations. It's a little less confusing. So I will use that form over and over again. So let's just do a few examples. Our first example is here. I've already designated the u and the v terms. So we have a product here, and if you don't remember second grade, product is just when two things are multiplied together. So that little red dot, that is our multiplication symbol in that case. And I'm just gonna apply the product rule to this. So to derive y, so we take y prime, and what we'll do in the old days, meaning like last week, we would multiply those together, get a string of terms, and use the power rule. Now in this case, it actually might be faster, but in other cases it wouldn't be if you had a lot more terms. So let's go ahead and do this. So this says to take u, which is 3x minus 2x squared, multiply it by v prime, the derivative of 5 plus 4x is 4, and then add that to v and multiply by the derivative of 3x minus 2x, 2x squared. So the derivative of u is just 3 minus 4x. Okay, so quite simply, that is done to the extent that the AP College Board wants your answers if you've taken the AP test. Now, in a normal calculus class, you would not get full points for leaving it unsimplified. So I'm going to go ahead and simplify this just so that that's taken care of. You are not required to simplify in this class on tests. However, if you get into the habit of not simplifying things, you're going to lose a lot of points in the next calculus class you enter. So this would be 15 minus 20x plus 12x minus 16x squared. Okay, so this whole thing would be negative 24x squared. 24 minus 20 is plus 4x plus 15. And that is y prime. Okay. This example, now we haven't really talked about trig functions yet, and we're going to get to those. Let me move that one down a little bit. We haven't gotten to the derivative of trig functions, but for this example, I just want you to see this because I do believe they show up. So if you have sine x, the derivative of sine x is cosine. If you have cosine x, the derivative of cosine is negative sine x. So just so you know, these apply. We don't really need to know why yet, and we'll get to actual trig derivatives later, but for now we're just going to use those rules. So right here, let's solve this thing. So y prime, we're going to use the product rule, right? So again, the product rule says u v prime plus v u prime. So basically, I'll just fill that in. And this one, our product in this case is actually right with this first part. That's where we'd use the product rule. Because where it says minus 2 sine x, that's not a product, so we're not going to use it there. So for this first part, we're going to use the product rule just on that. So u we leave alone, and then we multiply by the derivative of v. So just to be really clear, I am designating that as u and cosine is v. Okay, so u is 2x. I'm going to multiply by the derivative of cosine. And from what I just showed you that's on the right here, the derivative of cosine is negative sine x. And then to apply that product rule, again, we take v, which is cosine x, and we multiply by u prime. The derivative of 2x is 2. And so that is our one application of the product rule, and then we have this minus 2 sine x at the end. So sometimes you have to use the product rule inside of another function like that. So we just used it once on one part of it. And then we simplify. In our next example. Okay, so this is an example I threw in here. This is a product. We have a product here, but this is probably not the most efficient way to do this problem, and I'll show you why. So sometimes these questions will look like products, and they are, but they might be easier to solve using something else. So what I'm going to do with this one is just rewrite it just to demonstrate what I mean. So y, not prime, just y, if I just rewrite this as 3x squared, and then 16x to the negative 1 can be rewritten as 16x, to the first power, and I'm going to get rid of that because I don't really need it. Well, this problem is now, I can do some canceling, it's really 3x over 16 if we cancel out one of those x's. So if you were to look at y prime of 3x over 16, well, that's just 3/16. So sometimes problems will look like it'll look like you should use the product rule or the quotient rule or whatever, but they're much easier to not do that. Sometimes just take a second look at them. And when I make these assignments, I'm a villain in that regard because I always do that. I try to make things look like one way, and they'd be very confusing if you did them that way. Because what I'm trying to do is get you to understand and recognize that if you just look at it a little differently, you can come to a simpler solution. Next, we have the quotient rule. So this is similar to the product rule. It's just a rule we apply. And I did write this out using Leibniz notation so that you can at least look at it. It's more complicated. There's a lot more. It's just really unwieldy. So I don't remember those ones. When I commit this stuff to memory, I go with the y prime notation. So I'm going to move that up a little bit. Basically, g of x can't be 0 because it's in the denominator, but this is the way I would remember it. So if you have y equals u over v, where u and v are differentiable, just means you can take the derivative. And v cannot be 0, have to have that. Then y prime is u prime v minus uv prime divided by v squared. So these rules you do have to memorize because they don't give you these on tests. Those are to be committed to memory. So I know it seems like a lot, but you'll start to, as you use it, it might just stick in your head. It's very similar to the product rule, except you have a subtraction sign up there in the numerator. Okay, so let's apply this to a couple problems here. Let's look at 5x minus 2 divided by x squared plus 1. So I am going to designate the u as 5x minus 2, and the v is x squared plus 1. All right, so I will just apply this directly. Y prime. It says to derive u, so that's 5, multiply by v, subtract u. Always put these in parentheses, and then multiply by v prime. Well, v prime is 2x. And then square v. So this would be x squared plus 1 squared. So again, this would be AP approved. No simplification. However, I still, I would like you to simplify on the homework and get used to it, because a lot of these problems are multiple choice. So if you are out of the habit of simplifying, you're not going to be able to find your answer in the multiple choice. So let's simplify that. That's 5x squared plus 5 minus 10x squared plus 4x. I'm not going to multiply out the denominator because I like the way it looks, but in the numerator we'll clean that up one more time. Basically, if I don't see something that cancels across the, it's called the vinculum line, but then I won't simplify or multiply it out. So this would be a fine answer. All right, so let's look at our next one. So, okay, this one's fancy. It's got a square root. I know it doesn't look like it, but it does. This is u, this is v. One of the first things I would do with something like that is just convert the square root so it's not confusing. So h of x equals 4 times x to the 1/2 divided by x squared minus 2. And now let's do our h prime. Use a different color because I'm bored. H prime of x is going to be u. Let's see, let me double check that. Make sure, it's u prime. At first, when you do these, you're going to want to check the rule every time just to make sure you're writing it out correctly. So it's u prime, which is, u is 4 times x to the 1/2. So u and v. And so that would be 2x to the negative 1/2 multiplied by v, which is x squared minus 2, minus v prime, which is 2x times u, which is 4x to the 1/2. And then we square the denominator. Then we clean it up. Okay, so when you do this part, remember, if you're multiplying exponents, or multiplying bases that are the same, you add exponents. So this first one would be 2x to the 3/2 minus 2x to the negative 1/2. That actually would be 4. And then minus 8x to the 3/2. Divided by x squared minus 2 squared. And I can do one thing to clean that up a little bit. So I can combine those x to the 3/2. So you'd have a negative 6x to the 3/2 minus 4x to the negative 1/2 over x squared minus 2 squared. Okay, so let's look at this problem. H of x equals 3x squared over x. So these questions, I put them on tests, and again, for a student to do this using the quotient rule, it's sad because this is a really easy problem. Here's the short way, right? Use red. So h prime of x, and I'll just write h of x and do that first. So h of x, if I cancel the x, is really just 3x. And then h prime of x is 3. So don't use the quotient rule if it can simplify first. So don't go through all of the quotient rule thing, because you can use the quotient rule on here. In fact, I'm going to, and it'll just take a long time, but let's see what it does. Let's make sure it works and still gets 3. Okay, so let's call this u, and this is v. And what I'm telling you right now, again, is to not use the quotient rule on something like this. So let's start here. H prime of x would be u prime, so we take the derivative of the numerator, so 6x. We multiply by v. Subtract v prime, which is 1, and multiply by u, which is 3x squared. And then we square the denominator. Then we simplify. Then we simplify. Then we simplify. So in that case, it wasn't a ton of work, but it's a lot more steps than it was. And if the problem were just any more difficult, it would be a mess. So again, don't use the product or quotient rule if you can somehow make it so you just use the power rule. All of these things, we're just trying to get to the result, so don't make it complicated.